So where we left off yesterday was at this point. We were trying to graph y equals 3 cosine theta in a polar coordinate plane. And what we did is we mapped out 0 to 2 pi and the values of 3 cosine theta. And these are the values that we got. And what we did is we mapped out this one. We plotted the values until pi, right? And it traced out a circle. So then after that, what happens is if you keep graphing this, what happens? You trace over the same circle one more time, right? So let's think about radii, right, from the pole as theta increases. So when theta is at its highest, when theta is 0, the radius is 3. So the radius is right there, right? And then as theta increases, the radius decreases, and it decreases a little bit more. And then here, when theta is equal to pi over 2, how much is the radius? 0, so it doesn't get out at all. And then when you increase the angle, the radius increases a little bit more, and then it increases again to pi. And then the radius starts to decrease, increase again. All right? So again, just like we talked about before, when we're graphing polar coordinates, it's just about at this angle, how far out does the radius go, how far out does the radius go, and so on. All right, so that was a circle. And if you look here, how big is the diameter of this circle? 3, okay? The diameter of this is equal to 3. And where is 3 in our equation? It's that number there, right? So the standard form of the equation of a circle, we said, was r equals a cosine theta, okay? And the diameter of the circle is always going to be the absolute value of a, okay? Why the absolute value of a? Because what if this was r equals negative 3 cosine theta? Well, then the circle would just be reflected on this. So the circle would be to the left, okay? But the diameter would still be the same value, all right? So that's if it's cosine. Now, it could also be r equals a sine theta, all right? And if it's a sine theta, you could see here on the bottom, if it's a sine theta, you still get a circle, but this time the circle is on the vertical pi over 2 axis, and then if it's negative a sine theta, it's on the bottom, okay? All right, questions? So anytime you have a sine theta or cosine theta, you're going to get a circle. And it's up to you to know, right? Is the circle going to be along the horizontal or the vertical axis? And if it's going to be above, below, right, left. So often on a test or a quiz, for example, I'll give you a graph and say, give me the equation here. Okay? So it's up to you to know. Now, as we progress through the lesson, you will learn new tricks with symmetry and things like that, but it's a good idea right now. You want to make flashcards, figure this out. Yes? Right, so negative positive tells you the location. Yes.
And then is the absolute value of A
always the diameter? Yes. Okay. Now, so this is one type of equation. All right. Now we've been graphing things in rectangular coordinates since we were very little, right? How many types of graphs or equations can you graph? You could do a linear equation. You could do a parabola. You could do a circle. You could do quadratic. You could do cubic, square root, and so on. Same thing here. We just did circle. Let's do the next one, it's called limicins or cardioids.
Like the same thing.
Okay, limicins or cardioids. So the limicins or cardioids have this form, R equals A plus or minus B cosine theta, or again, this should say R equals A plus or minus B sine theta. So before I just had R equals a number cosine theta. That was a circle, right? But if I do R equals 3 plus that, then I get a limicin. All right? I will talk about cardioid. So now, A and B are positive. They create limicins, which a limicin is formed when a circle rolls around the outside of another circle. We'll talk about what that means. Hang on. Okay, I have lots of visual aids, so hang on. Now, so here, look, I have A, 3, plus B, 2 cosine theta, right? My A and my B are different values. If I were to make them the same value, right? If these are the same, that special case of limicins is called a cardioid. All right, I'll tell you now why it's a cardioid. So we're going to be graphing A plus or minus B cosine theta or B sine theta. We're going to do the first case when A equals B. So this one, 3 plus 3 cosine theta. So again, I have my values here, right? So what we're going to do is we're going to fill out this chart. So here I have 3 plus 3 cosine 0. So what's cosine 0? 1. So this will be 6. All right? Now, when we do pi over 6, okay? When we do pi over 6, so literally what you're going to do is in your calculator, in fact, you know what? Okay, so hang on. In your calculator, you're just going to type in 3 plus 3 cosine theta. And I've done it to be more efficient. It's 5.6. It's both. I'll talk about tests later, okay? Let's not focus on that right now. Pi over 3, 4.5. Cosine of pi over 2 is 0, so that's just 3. 2 pi over 3 is 1.5. 5 pi over 6 is 0.4. Now, cosine of pi, what's cosine of pi? Negative 1, so that'll be negative 3 plus 3, 0. Okay? All right, then at 7 pi over 6, it's 0.4, 1.5, 3, 4.5, 5.6, and 6. Okay, so let's plot this. When x is 0, y is 6. And then when x is pi over 2, y is 3. When x is pi, y is 0. So what's happening here? What's happening, okay, when theta is 0, when the angle is 0, how far away are we from the x-axis? Well, 6, right? We're the farthest away. Then as theta increases, what's happening to the distance from the x-axis? What's happening to the distance? It's decreasing, okay, until here. And then at 3 pi over 2, it's 3. And 2 pi, it's 6. So after this point, as theta increases further, what's happening to the distance? It's increasing. Okay?
Is that a normal sine or cosine function?
Yes. But I'm just...
nothing special about that.
No.
In Cartesian.
Okay, so let me graph this. Okay? So let's all right, so let's look at some trends here. when theta is 0, right, the graph is farthest from the x-axis, okay? As you approach theta equals pi, the distance approaches 0, all right? So what does that mean? When theta equals 0, you have the maximum radius. As theta approaches pi, the radius approaches 0. And then as you approach 2 pi, r approaches maximum again. Okay? So now, let's see that here. Okay? Let's see that here. All right. So when theta equals 0, my distance is the farthest at 6. So what I'm going to do here is I'm going to calibrate this by 2's. So when theta equals 0, my distance is at 6, right? My radius is at 6. At pi over 6, we're 5 pi over 6. 5.6. So right there. At pi over 3, 4.5. At pi over 2, 3. Okay, so look at what's happening. Look at what's happening. Here, look at how far away I am. And then radius gets smaller, smaller, smaller. When is the radius 0? At pi over 2, the radius is 3. And then at pi, the radius is going to be 0, right? But before that, at 2 pi over 3, how much is the radius? 1.5. That's somewhere here. At 5 pi over 6, 0.4. And then at pi, it's 0. So do you see what happened here? Look at what happened. It came from here, here, here. And then look, it's curling inside. You see that? So the radius was really big, and then it got smaller, 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 and now it curled inside. So now, as we go further, as theta increases again, right, at 7 pi over 6, it's 0.4. So it increases incrementally a little bit. Here. At 4 pi over 3, increases a little bit more to 1.5. At 3 pi over 2, now it's 3. At 5 pi over 3, it's 4.5.
Isn't 3 like way bigger than that?
No, because she's going by 2.
And then at 11 pi over 6 is 5.6. And then at 2 pi, it's 6 again. So what happens? It increases, increases, increases. And here, a heart. What's a cardioid? It's a heart. Get it? It's a cardioid. It's a heart. Okay? So what happens? Basically, how does that happen? It's because the radius is so much here, and then it's all about radii. Do you see that? And then here you do a short radius that way, and so on. Okay, so we just graphed a limicon with A equals B, which makes it a cardioid. And actually, this is the one we just graphed, 3 plus 3 cosine of x, right? And you see here exactly what I was talking about, right? That this is the equation that we graphed on the Cartesian coordinate system, right? The distance from the x-axis is at a maximum, and then it gets closer and closer and closer, and then farther and farther and farther. And you will see that the same thing happens here. The distance in the beginning is very far, then it gets closer and closer and closer, and then farther and farther and farther. So without further ado, take a look. Look at this, right? So look here, as it approaches 0, look at how, okay, so do you see how as the distance here on the Cartesian coordinate system from the x-axis decreases to 0, so does this radius, right, decrease to 0 from the pole, right? It's very far from the pole, closer, 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 until it's 0. So now, probably thunder. So now what's going to happen? Look, the distance from the x-axis is going to increase again. So the distance from the pole is going to increase again. So look, it's going to increase, right? As that's increasing, this one is increasing here. And then if you kept graphing that, and then if you kept going through the angles, like after 2 pi, right? 2 1/4 pi, 2 1/2 pi, 3 pi, 4 pi, it'll just keep doing the same thing again. So do you see how the distance in the blue from the x-axis is the same as the radius from the pole, right? So that's a cardio, yes.
As like a little graduation present to me and Sammy, is there a way?
Right, so we did the first case where A is equal to B. Now let's do a case where A is greater than B. So like for example this one, right? A is 4 and B is 2. All right, this is still in the Limousin category. So we're going to do the same situation. So here, 2 cosine 0, cosine of 0 is 1. So this is a 6. And then at pi over 6, it's 5.7. At pi over 3, it's going to be a 5, right? Because cosine of pi over 3 is 1/2 times 2 plus 4 is a 5. Pi over 2, what's cosine of pi over 2?
Not 2 over 2.
0. So it's just 4. 2 pi over 3 is 3. 2.3. Now, cosine of pi is -1. So that's -2 plus 4 is 2. Okay? Then it's going to be 2.3. Then 3. So what's going to happen is it decreased. And then 4, 5, 5.7, and 6. Okay, so let's graph this. So at x equals 0, it's 6. At pi over 2, it's 4. So you'll notice on the Cartesian, I'm not putting in the pi over 6 or the pi over 3s. I'm just putting the half ones because I just want a general graph. Then on the other one, I want to make it more detailed. So 2 is, the value is 2 at pi. And then it's 4 at 1 over 1.5 pi, and then finally here. So let's look at the trend here, and let's write down the trend. So until now, I was giving you the trends here, but we're going to do this one together. So let's look at this more closely and see the trends. Yeah.
Is it like how sunny do have doesn't go all the way to the bottom?
That's exactly what it is. All right. So take a look. Okay. So at theta equals 0, okay, radius is max of how much? 6. Okay? Now, as theta approaches pi, okay, the radius approaches 2. So basically what happens? Radius approaches the minimum value, right? The radius approaches its minimum value, but that minimum value is not 0. Okay? So it's the farthest here, and then it approaches the closest value to the x-axis, but even there, it never really gets too close. It stays a minimum distance away from the x-axis.
It's shifted.
You see that? Because it's shifted. And why is it shifted? Because A and B are not the same. So now let's graph that here. All right, let's graph that here. So what do we suspect is going to happen? We suspect that it's going to start from the maximum value, and then the radius is going to shrink, but not really hit 0. Always maintain a minimum distance. Almost, except, yeah, like it touches it. So
Let's go by 2s again.
So we're going to go by 2s again. So that's 2, 6, 2, 4, 6, 8. Hang on. At x equals, I'm sorry, when theta is 0, the radius is 6. At pi over 6, it's 5.7. Pi over 3, it's 5. Pi over 2 is 4. 2 pi over 3 is 3. 5 pi over 6 is 2.3. And then at pi, it's at 2. So look at that. That's the farthest it's ever going to get. I'm sorry, that's the closest it's ever going to get. Right? So now when I trace this, what does that look like? That. You see how before it got, like, it snailed into 0? It didn't do that in this case, right? It never went to 0, so it's going to stay there. Now what's going to happen? It's going to start moving back out again. All right? So at 7 pi over 6, 2.3, then 3, then 4, then 5, then 5.7, then 6. But look at the difference. This one like goes in all the way. This one, it's a circle with a dimple. That's what it's called. That the technical term is dimple in the math. It's a dimple. Yeah. It's like a circle with like a little dimple. Huh? It's actually like it's a dimple in math. Yeah. The mathematical term is dimple. Yeah, it's a math dimple. Zachary. This is the one we just graphed, right? 4 plus 2 cosine. So look at this. It goes down to 2, right? There is like a minimum distance away, and then it gets further and further out. So take a look. The radius here is at a maximum, and then eventually the radius is going to get smaller and smaller and smaller. So this is the radius here, and then if we go a little bit, okay, look at this. You see the radius? It's a little bit smaller. Okay, so you see how the radius is now smaller, right? The radius here is smaller because that's going closer to the x-axis. And now smaller, smaller. That's the smallest it'll get, the radius, right? Because that's the closest it is to the x-axis. You see that? So now it's getting further and further and further and further away. So the difference between this and what we did is, look at how many more points are here. We only did a couple. So when you do all of the points, you really see how it's like, it's like somebody's like pressing on the edge of a circle there. Okay. Because the computer just generates all the points, not just pi over 3, pi over 4. It does like pi over 8, pi over 12, and so on. Yes?
On the next page, it has a list of the line.
Yes, limits it. I'm getting there, yeah. Third case is when A is less than B, right? A is less than B, like for example this one. So let's do the same thing here. Again, we're going to go 0 to 2 pi. So when x is 0, cosine is 1. So this is 6. So you see how like even here, like in the rectangular coordinate system, when we graphed cosine, at 0, you always start from the maximum, and it's the same thing here. Do you see that? Cosine always starts. So sine would be the opposite way. At 0, you would start at 0. Okay, pi over 6 is 5.5. Pi over 3 is 4, right? Pi over 3, the cosine will be a half. So 4 cosine of that is 2 plus 2 is 4. At pi over 2, cosine is 0, so it's just the 2. 2 pi over 3 is 0. Now look at this one. Negative 1.5, negative 2, negative 1.5, 0, 2, 4. It's increasing eventually to 6. Okay? All right, so let's graph this. We start at 6. Pi over 2, I'm at 2. Pi, I'm at negative 2. 3 pi over 2, I'm at 2. And then 6 again. Okay. Graph. Okay. What are the trends? So we're always looking at max and min, right? So when is the max? Max distance. right? Where?
0 and 2.
Where the radius
Right.
is the biggest.
Maximum radius is equal to 6 at theta equals 0. Thank you.
This one goes below 0.
That's the thing. This one now dips below 0. So not only does it get small to 0, no, it gets even smaller than 0, right? But, okay, so r equals 0. So the radius is 0 at where? 2 pi over 3 and where else?
4 times.
And 4 pi over 3, right? So at the pi over 3's, the radius is 0.
So as theta approaches pi,
Uh-huh.
x is less than 0.
Exactly. So where is the region where it's less than 0?
Between 2 pi over 3 and 4 pi over 3.
Yeah, so here, right?
Is that
So
always true?
r is less than 0 from 2 pi over 3 to 4 pi over 3. Okay? So now, let's see how that's going to look here. Okay, when theta is 0, we're at 6. Huh? Yeah. Here, no, it's here. Oh, sorry. Okay. And then pi over 6 is 5.5. Right, that's 3/4 of the way. And then it's at 4. And then it's at 2. Okay, at 2 pi over 3, the radius is 0. Okay? Now, at 5 pi over 6, the radius is negative 1.5. So where am I going to go? The other direction, negative 1.5 here. Okay? At pi, it's negative 2, so I got to go here. So do you see how like it's curling inside itself? And then at 7 pi over 6, it's negative 1.5. So here. And then at 4 pi over 3, it's 0. Right? 4 pi over 3, it's 0. And then 3 pi over 2, it's 4. What the heck is going on? Okay, let's graph. Look, let's see. We started here. So it's very hard because, look, we started here and we went here. Right? From that point, where did we go? To the inside. Then we went to that one. Then we went to that one. And now we're going back out again. Oh my God.
Oh my God.
Look at that. Okay. And then at 5 pi over 3, it's 4. Oh, wait a minute. What was it at 3 pi over 2? It was 2. I went too far. Yeah.
Like smaller.
Yeah, you go inside. And then at 5 pi over 3, it's 4. So I go here.
Sound like an apple without.
And then it's 5.5. And then it's 6. Look at that.
It looks like an apple with a leaf.
Mm-hmm.
I know what you said. I thought about it earlier, but I didn't say it. I want to watch the progression on the calculator.
Okay. So, let's do this though. You know what I want to do? I want to trace starting from 0 again. Okay? So, this was at 0, and then pi over 6, and then pi over 3, and then pi over 2, and then 2 pi over 3 was 0, right? Then negative 1.5, and then what? Negative 2. Right here was the halfway point. Okay? So this right here is from 0 to pi. So you see what half of it made? And then now the other half, in the blue here, the other half is symmetric, but in the opposite direction. Do you see that? So this is from pi to 2 pi. Do you see what I'm talking about? So it's one and then the other one. Okay, so let's take a look at this animation that we've got here. So I want to do A is less than B, 2 plus 4 cosine x. Okay, so look. We start, it's getting smaller, 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 smaller. Here, look, the radius is 0, right? Now, the radius is going to be negative, so that means when my angle is here, the radius is negative, so it's inside, okay? So here we go, negative, negative, negative. There we go. Do you see that? And there. Right? Uh-huh. Okay, isn't that cool? Yeah. Now, so this is how they all look. So when A is equal to B, you get the cardioid. When A is less than B, you get the inner loop. When A is greater, you know, you get these. Like, and then like the size of the dimple, right? That has to do with the case. Okay? All right. Yes. Cardioid. The equations of the form R equals A cosine n theta, or R equals A cosine, A sine n theta, right? So now, so remember when you had R equals A cosine theta, that was a circle. But if it's n theta, now what you get is a rose. Okay? Okay, so a rose. So now, so where n is greater than or equal to 2, because if n is equal to 1, right, then it's still cosine theta and it's a circle. So it has to be that n is greater 2 or above, and n is an integer. Okay, so you're not going to have cosine 1.5 theta. It's going to be 2 theta, 3 theta, 4 theta. They produce roses. So now, roses have petals. If n, this number here, is odd, then there are n petals. So if it's okay, so if it's okay, so if it's okay, so if it's sine 3 theta, 3 petals, sine 7 theta, 7 petals. If n is even, then there are 2 n petals. All right? So, for example, R equals sine 4 theta, it has 8 petals. All right? Because that's even. If it's R equals sine 3 theta, 3 petals. All right. So now, what is the difference between R equals 2 sine theta and R equals 2 sine 3 theta? What is the difference in terms of chapter 4? Right? Yeah. Yeah. What's the period of the one on top? Come on, what's the period of 2 pi? What's the period of this one? 2 pi over 3 is the period. That means over an interval of 2 pi, is this going to have more or less cycles?
More cycles.
More cycles, because it's a shorter wave. That means if with each cycle we go out and in, then with this one we go out, in, out, like more times. Okay? So 4 cosine 2 theta, how many petals do we expect it to have? 4. Twice.
Oh, sorry.
All right, so at 0, it's 4, then 2, then negative 4, negative 2, 2, wait, I did it at 2 pi over 3. All right, hang on, I messed it up. Okay, so it's 2, negative 2, negative 4, negative 2, 2, 4. At 7 pi over 6, it's 2, 4 pi over 3, negative 2, negative 4 at 3 pi over 2, then negative 2, 2, and 4. Huh? Yeah, almost. So when we graph, right? So it's at 4, and then so you know what I'm not gonna have time for this. So let's pause here and do this tomorrow.